Hi, let us solve some problems about work and energy. In the first problem, well, we say consider the bars being pulled by these tabots. The pull of the first tabot is 2.5 times 10 to the fifth newtons at 30 degrees to the left, and the pull of the second tabot is 1.0 times 10 to the fifth newtons at 15 degrees to the right. So what is the work done by each tabot on the bar? Why the bars move 100 meters forward? What is the total work done by both tabots on the bar? So in the first problem, we're going to find the work. So we remember the work is basically the product of the force times the displacement, right? So we know the work is the integral of f dx, right? But in this case, we don't have to use integrals, right? So basically here, what are we going to do is to find the work that is done by the first force and the work done by the second force, right? Using the component in the direction of the x-axis, of each of these forces. So this is the x-axis, this is the y-axis, right? And this is the bars, right? So I know that the work that is done by the force 1 in this case would be equal to the force 1 times the distance that is going to travel, that is going to move forward this uh, mm, bars, multiplied by the cosine of the angle, 0, 1. So this would be here 2.5 times 10 to the fifth newtons times, in this case, 100 meters times the cosine of 30 degree. So when you do the calculation, you get that this work 1 is equal to 2.17 times 10 to the 7 joules. 2.17 times 10 to the 7 joules. So this would be approximately like, 2.2 times 10 to the 7 joules, right? Now let us find the work that is done by the second force. So to find the work that is done by the second force, I'm going to say, okay, work to force 2 is equal F2 d cosine of zeta 2. So the work done by the second force is 1 times 10 to the fifth newtons times 100 meters times the cosine of 15 degree, that is in this case the angle, right? So if we do it like this, we're going to find that this force, that this work will be equal to 0.97 times 10 to the 7 joules. So it's approximately 1.0 times 10 to the 7 joules. Well, in the second part of the problem, well, this is the first part of the problem. In the second part of the problem, they say what is the total work that was done, by both the bots on the bars. So in this case, what we have to do to find the total work is to add the work done by the first force plus the work that was done by the second force, right? That is going to be approximately 3.2 times 10 to the 7 joules. In this case, the forces are pointing in the same direction. So means that the x component of the force is the component that is doing work in the forces, for both forces are in the same direction. We can also find the resultant force on the x-axis of both forces, right? And then we can find the work using the resultant force. But for this case, just doing like this is going to be okay. Here we have a second problem where they say that we have a particle that is moving along the x-axis. and is subject to a force Fx that depends on position as is given in the figure below. So they say from the graph, find the work that is done by the force as the particle moves from 0 to 8 meters. So we know that the work is the integral of f dx, right? So basically the work would be the area under the graph, you know, of force versus x versus position. In this case, to find this area could be very easy, could be very simple, because we have, geometric figures like triangles and rectangles. Anyway, I'm going to complicate the solution a little bit in order to do it using the integrals. So I have to find what is the equation, of the curve uh, in each interval. So it's pretty clear, that this line respond to a function of the form f of x equals x, right? Why? Because this line is passing through 0, comma 0, and is passing through 2, comma 2 here. So this is the identity function, right? This is passing through 1, comma 1, to 2, comma 2, to 3, comma 3, etc. It's also very easy to find, that this portion, this interval, the function we have in this interval is f of x equal to. So it's a constant function of the form y equal to, right? Because no matter what is the value of x, the value of y is always 2. And then you can now find the slope of this line, and you can use the slope and one point on the line, right? And using then the point slope form of the equation of the line, you will be able to find what is the equation of this line over here. And the equation of this line, or the function, that describe this line, is going to be f of x equals negative x plus 6. So once I know, these functions, I am going to apply the integrals. Sorry. So I'm going to say, that the work here will be the integral from 0 to 2. These are the limits of integration, for my first portion, because it's from x0 to x equal 2 of x dx, plus the integral from 2 to 4 of 2dx, plus the integral from 4 to 8, so from x equal 4 to x equal 8 of minus x plus 6 dx, right? So now I'm going to find these integrals. So the integral of x dx is x squared over 2, and I will evaluate it from 0 to 2. Plus the integral of 2 dx is 2 times the integral of dx, so the integral of dx is x, so this is 2x from 2 to 4, and then we have that the integral of negative x plus 6 dx would be negative x squared over 2 plus 6x, right? So it will be, let me put in parentheses, negative x squared over 2 plus 6x. This is plus here. And I will evaluate this part from 4 to 8. Let me do something here. It's a negative sign. So negative x squared over 2 plus 6x. We're going to evaluate that from 4 to 8. So when you evaluate, what you get first 2 squared over 2 minus 0 squared over 2. So this would be basically 2 squared over 2. Plus when we evaluate 2x with limits of integration 2 and 4, so we have 2 times 4 minus 2 times 2 plus, and then we're gonna evaluate these at 8 and 4. So it will be uh, minus 8 squared over 2 plus 6 times 8, you know, minus, and then the lower limit here, that is 4 squared over 2 plus 6 times 4. So if we do the calculations, we're going to find here that this is 2 squared over 2, that will be 4 over 2, so it's 2 plus 2 times 4, 8, minus 2 times 2 is 4, so this is 8 minus 4, so it's 4 plus, and then uh, we have in this case negative 8 squared is negative 64 over 2 is negative 32 plus 6 times 8, that is 48, so negative 32 plus 48 will be positive 16 minus, and then here 4 squared 16 over 2 is 8, negative 8, and 6 times 4 24, and 24 minus 8 is 16, so this is 16 minus 16, so this is 0 here, so we have 2 plus 4, so it's 6 joules. So it's 6 joules the work that is done by the force, right? Now it's very evident, right? We have here uh, if you find this area graphically, right, you have a triangle, and the area of this triangle is b times h over 2, so it's the base 2 times the height 2 over 2, so it would be 2. These 2 joules we have over here. We have then this area, that is the area from the square, so we have 2 units in this side and you have 2 units in this other, so we have 4. There is this area, and then you will have, that these 2 areas, as one is positive, one is negative, are canceling each other, you know. So that's why these 2 parts just they just cancel each other, because it's the same area, one above the x-axis, one below the x-axis. So basically, the part that matters here is this one. So the area under the graph in this region that give me the work that was done by the force. Look at the next problem. In the next problem, they say, suppose that the force acting on a particle is a function of position. The force have components fx equal 4x squared plus 1, fy equal 2x, and fz equal 0, where the force is measured in newtons and the distance is in meters. So what is the work that is done by the force if the particles move on a straight line from x equals 0, y equals 0, z equals 0 to x equal to meters, y equal to meters, and z equals 0. So, well, we know that the work will be the integral of the force dx, right? But in this case, we have 3 components. All the components are functions of x, right? So we can say that this is the integral. In this case, we know the limits of integration because in the case of the x component from 0 to 2 meters, in the case of the y component from 0 to 2 meters, in the case of the c component is 0, and there is also 0 displacement along the z-axis. So we're going to have basically, the x and y components, so this will be the integral from 0 to 2 of f sub x dx plus the integral from 0 to 2 of f sub y of x dx, right? So this would be basically the integral from 0 to 2 of 4x squared plus 1 dx plus the integral from 0 to 2 of 2x dx, right? So now we're going to find those integrals. So we have that the work is equal to the integral of 4x is 4x squared over 2, so it will be oh sorry, there is a 4x squared here. There is a 4x squared here. So the integral of 4x squared is going to be 4x to the third over 3, and the integral of 1 dx will be x, and we're evaluating this from 0 to 2. And now the integral of 2x dx is going to be 2 times x squared over 2, so it's going to be x squared from 0 to 2. So now we are going to evaluate. So we get 4 times 2 to the third over 3 plus 2. Of course, when you evaluate at 0, this will be 0. And then plus we have then 2 squared. When we evaluate at 0 here, at x equals 0, this will be 0. So we're going to get really in this case 32 over 3, because this is 2 to the third, that is 8 times 4, 32 over 3. Now plus 2, plus 2 is this 2 over here, plus 4. And that would be approximately 50 over 3 joules, right? Remember the force in newtons, and the displacement, in meters, so newtons meters would be joules, right? So this is approximately in decimal notation 16.67 joules, what is approximately 17 joules. So that would be, in this case, the work that was done by the forces. Let us see this other problem. They say the force between two inert gas atoms is often described by a function of the form f of x equal to a times x to the power of negative 13 minus b times x to the power of negative 7, where a and b are positive constants and x is the distance between the atoms. Express your answer in terms of a and b. They say what is the equilibrium separation and what is the corresponding potential energy function. So let us go over the solution. The equilibrium separation between the atoms would be when the force between these atoms be equal to 0. So when Fx equals 0, this is the condition for the equilibrium separation. So we have to make, in this case, f of x equals 0, so you have 8x to the negative 13 minus b to the power of negative 7 equal to 0. You have to solve this equation, so for x. So this is the same that a over x to the 13 minus b over x to the 7 equals 0. I will look for a common denominator. So to look for a common denominator here, I will multiply the numerator here by x to the 7 and the denominator by x to the 7. And in the second term, I will multiply my numerator by x to the 13, my denominator times x to the 13. So 13 here. So it will give you now x to the 7, or ax to the 7 over x to the power of 91 minus b x to the 13 over x to the power of 91 equals 0. So we have common denominator x to the power of 91, so x to the power of 7 minus b x to the power of 13 over x to the power of 91 is equal to 0. And this expression is equal to 0 only if the numerator is equal to 0. So we can say that a x to the 7 minus b x to the 13 is equal to 0. So I will factor x to the 7 out. When I factor x to the 7 out, now I have a minus uh, b x to the 6 power, factoring x to the 7 out. So you have two solutions for this equation. One solution that is x to the 7 equals 0, so x equals 0, so that does make sense. And the other solution is when a minus b x to the 6 is equal to 0. So you solve here for x, and you get that x to the 6 is equal to a over b. So you get that x is equal to the 6th root of a over b, or a over b to the power of 1 over 6. So this is the equilibrium separation. Okay, so this is the solution of the first part of the problem. In the second part of the problem, they ask you to find what is the corresponding potential energy function. So for the second part of the problem, we say that the potential energy, the variation in potential energy, is the negative integral of fx dx. So basically, what we have to do is to find the negative integral, of ax to the power of negative 13 minus b to the power of x, b times x to the power of negative 7 dx, right? So this will be here negative, and then we have, in this case, a times the integral of x to the negative 13 is x to the negative 12 over negative 12, right? Minus the integral of bx to the power of negative 7 would be bx to the power of negative 6 over negative 6, of course, plus a constant c. So we have here negative ax to the negative 12 over negative 12 plus, because negative over negative is positive, right? So b over 6x to the negative 6 plus c, the constant of integration. Let me say a constant because we don't know the limits of integration. And then now, due to this negative sign, we revert the signs, right? So we're going to have a x to the negative 12 over 12 minus b over 6x to the negative 6 plus c. And this would be the expression, that let me find the variation in potential energy. So this one is a really very interesting exercise. Let us analyze this last problem. So they say a box of mass 40 kilograms is initially at rest on a flat floor. The coefficient of kinetic friction, mu k, between the box and the floor is 0.60. A woman is pushing horizontally against the box with a force of 250 newtons until the box reaches a speed of 2.0 meters per second. So they say, what is the change in kinetic energy of the box? What is the work that is done by the friction on the box? And what is the work that is done by the woman on the box? So let us make a diagram, very simple diagram, to visualize better what is going on here. So this is the floor. Here we have the box. This box has a mass of 40 kilograms. And then on this box we have in here the weight. And of course there is a normal force. And also we have that a woman is pushing the box with a force of 250 newtons, but there is another force here, that is the force of friction, of kinetic friction. The force of kinetic friction that is going to be in opposition to the force of 250 newton that the woman applied on the box to move it. So what happened is that initially the box is at rest, so the initial velocity is zero, and then due to the action of the force of 250 newtons, this box eventually is going to reach a velocity of 2.0 meters per second. This would be after travel a distance delta x, right? Okay, so we don't know the distance the box has traveled, before reaching these 2.0 meters per second. So the first, of course, we know the coefficient of kinetic friction music k, that is 0.60, right? So the first we're going to do in this problem, of course, to find the change in kinetic energy of the box, we say, okay, the variation in kinetic energy is the final kinetic energy minus the initial kinetic energy. So it's 1 over 2 mass times the final velocity square minus 1 over 2 the mass times the initial velocity square. So we know that the initial velocity is 0, so this term is going to be 0. So we have that this is 1 over 2 the mass, that is 40 kilograms, times the square of the final velocity, that is 2.0 meters per second square. So 2 squared is 4, times 4 is 160, divided by 2 would be 80, so this would be equal to 80 joules. So the variation in kinetic energy, of the box going from 0 meters per second to 2 meters per second is 80 joules. Now, the second question here is to find, in the second question, we have to find the work that is done by the friction on the box, but we don't know the force of friction, right? And we don't know the displacement of this box, so we don't know, the distance that the box traveled before reaching, these 2.0 meters per second. So the first is going to be to find the force of kinetic friction, and we say that the force of kinetic friction would be the coefficient of kinetic friction times the normal force. We know that the normal force is equal to the weight. In this case, that we have a flat surface, and the weight is equal to the product of the mass times the gravity. So this would be mu sub k mass gravity. So it would be 0.60, that is the coefficient of kinetic friction here, times the mass, that is 40 kilograms, times the gravity, that is 9.81 meters per second square. And we have that the force of kinetic friction is going to be in the order of 235.4 newtons, right? This is my force of kinetic friction. But of course, the force that is accelerating this box, and is making this box to move and increase its velocity, is a resultant force, or is a net force that is going to be the difference between the force that the woman applied on the box and the force of friction. So we need to find what is the net force here, and the net force acting on this box is going to be, of course, 250 newtons. That is the force applied by the woman minus the force that there is due to the friction, so minus 235.4 newtons. So that would be approximately 14.6 newtons, right? So this would be my net force. Okay, so this net force is the force that is going to cause acceleration. So I will be able now to find the acceleration of the box due to this net force. So I'm going to say that the acceleration is the net force divided by the mass, right? So it's going to be 14.6 newtons divided by these 40 kilograms. So I'm going to have an acceleration in the order of 0.364 meters per second square, right? So once I know the acceleration and I know the initial and final velocity, I can find, the displacement. So I can say that the square of the final velocity is equal to the square of the initial velocity plus 2 times the acceleration times the variation in position. I know this initial velocity is 0, so I have that the square of the final velocity is equal to 2 times the acceleration variation in position. So I can say that the square of the final velocity divided by 2 times the acceleration will be equal to the variation in position, or the displacement in this case. Yeah, so I can say that this delta x would be, um, in this case, the final velocity is 2 meters per second. We square that divided by 2 times the acceleration that we know that is 0.364, 0.36 meters per second square. So the variation in position in this case will be equal to 5.5 meters. So once I know, the displacement of the box before reaching, the 2 meters per second. So 5.5 meters here is the variation, the uh, distance, the box traveled before reaching, this 2.0 meters per second. Now, once I know this, I am ready to find the work, right? I'm ready to find the work due to the force of friction, and I'm ready to find the work due to the force that the woman apply on the box, because those are the questions that we have here. They say, what is the work that is done by the friction on the box, and what is the work that is done by the woman on the box. So we're gonna take the work done by the friction as negative, because we are dissipating energy in this case, right? So this is the work is equal to minus the force of friction times the variation in position in this case, or the displacement. So it's going to be equal to negative 235.44 newtons approximate times 5.5 meters, so this will be minus 1293 joules. So that is, in this case, right, approximately the value, okay, of the work done by the force of friction. Now, if I want to find the work that was done by the force applied by the woman, I say that the work of the force applied by the woman is that force F times the displacement. So it's going to be 250 newtons times 5.5 meters. So that would be 1,375 joules approximate. So we have solved the problem. You know, in this case, it's super important to highlight, that we have to use the net force to calculate the acceleration, because really, we have two forces that oppose each other: the force of friction and the force applied by the woman. To find the acceleration of the box, so we must use the net force. So, well, I hope that this program that I have explained today be really useful for you, and that with this program you just understand a little bit better the exercises related to this topic. Thank you so much for your attention.